Hello friends, I welcome you in lecture number 4 on applications of integration. In previous lecture we have discussed about disk method for finding the volume of solid which is generated by revolution about x-axis. So in this lecture also we will discuss this question which was asked in GTU Winter 2016 exam. So we just recall what is the formula for volume of solid of revolution about x-axis. So if some region R in the plane is rotated about x-axis, then the volume of the solid generated is given by integral of function pi times y square dx between the given values of x. Here y is the radius of the circular disc which will be the cross section perpendicular to x-axis. So with this in mind we try to solve this problem. The graph of y equal to x square between x equal to 1 and x equal to 2 is rotated about the x-axis. Find the volume of a solid so generated. So the first step is we sketch the region which we have to rotate about the x-axis. Here rotation axis is x-axis. So first we try to sketch the plane region using which we can generate the solid. So suppose this is xy plane, and we have to consider the graph of y equal to x square between x equal to 1 and x equal to 2. So we can think about intersecting points. Here if we consider x equal to 1, y is going to be 1. So x equal to 1 will intersect this y equal to x square at point 1 1, and if x is 2, y is 2 square, that is 4. So x equal to 2 and this parabola will intersect at 2 4. So first we consider some approximate scale. Suppose this much scale is 1. Now we can take scale as we wish. Suppose we consider this much scale as 1 and this is going to be 2, and we have to sketch the lines x equal to 1 and x equal to 2. Both are the lines perpendicular to y-axis. So this is x equal to 2, and we have to sketch the parabola between these two lines, x equal to 1, x equal to 2, and here we consider this much distance as 1. So this is 2, 3 and 4, and x equal to 1 will intersect parabola at point 1 1, and x equal to 2 will intersect parabola at point 2 4, that is at this point. So we have these two intersecting points, and we have to sketch the graph of y equal to x square, and we will consider the graph of y equal to x square between x equal to 1 and x equal to 2. So we are familiar with the graph of y equal to x square. It is a parabola with this shape, but we are interested in the shape of the parabola between these 2 points. So we join these 2 points. Our graph of y equal to x square between x equal to 1 and x equal to 2 is this one. So this is the region bounded by y equal to x square between the lines x equal to 1 and x equal to 2 above x-axis. This is x-axis. Here we have y-axis, and this is origin. This curve is y equal to x square. So now we have to rotate this plane region. This region we have to rotate about x-axis. So we will rotate this region about x-axis, and we will see that what will be the nature of the solid so generated, and then we will find out the volume of that solid. So for that we can roughly sketch the solid which is generated by revolving this plane region about x-axis. So suppose we consider here, suppose we have this x-axis and y-axis, and we have to rotate this region shaded by blue lines about x-axis. So this much distance is 1, this is 2, and we are rotating the region between these 2 points. This is the parabola, graph of parabola between these 2 points. Let me sketch with some other color. Here we are having this graph of parabola, and we are rotating this about the x-axis. So here we will have mirror image of this parabola. Okay, it will look like mirror image about x-axis, or reflection of this curve about x-axis, and then we will have solid which will look like this. Okay, we can roughly sketch the shape of this solid which will be generated by revolving this parabola about x-axis. Okay, so this is circular part, and it will look like this. So we are interested in the volume of this solid which is generated by revolving this region shaded by blue lines about x-axis. So here again I repeat, it is very easy to imagine the solid generated by this type of plane region. To find out the rough image of this solid, first what we are doing, we are considering mirror image of this part of the parabola about x-axis. We can sketch here also. So it will look like this, and then we join these two, and here we consider the circular base area. So we can roughly imagine the solid which will be generated by revolving the plane region about x-axis. Now we have to find out the volume of this solid which is generated by revolution of this plane region. So for that we can consider the cross section perpendicular to x-axis. So if we consider the cross section of this solid perpendicular to x-axis, then cross section will be a circular disc. It will look like this. So this will be the cross section of this solid perpendicular to its axis of rotation, which is x-axis. So we will obtain this circular disc, and radius of this disc will be distance between this y equal to x square and x-axis. If we consider this circular disc, then center of this circular disc will be on x-axis. So its distance is this one, and it is nothing but y. So we can consider this distance as radius y of this circular disc, and it is given by y equal to x square, and thickness of the disc is delta x. So we know that if radius of this circular disc, which is the cross section, by taking cut of this solid perpendicular to x-axis, then we have ready-made formula for the volume of the solid generated by this revolution. Volume of solid of revolution is V equal to integral pi times y square. This is the area of this base of this circular disc. This base area, which is like a circle, is pi y square. Area of the circle with radius y is pi y square, and we are multiplying this with height of the disc, which is delta x, and therefore we have this formula integral pi y square dx, and x lies between x equal to 1 and x equal to 2. So we have to consider the cross section starting from x equal to 1 and x equal to 2. So we integrate between these two values of x from 1 to 2. Now once we obtain these, things are easy. Pi is independent of x, we can take it outside. Value of y is x square, so we substitute y equal to x square. Square of x square is x raised to 4. X is from 1 to 2, and this is going to be integral from 1 to 2 x to the power 4 dx. Integral of x raised to 4 is pi times x raised to 5 divided by 5. Limits of integration are from x equal to 1 to x equal to 2. So we can put x equal to 2 first. We have 2 raised to 5 divided by 5 minus 1 raised to 5 divided by 5, that is upper limit minus lower limit, and we have 5 LCM, and 2 raised to 5 is 32 minus 1. So the volume of the solid is 31 pi divided by 5. So this is the volume of the solid which is generated by revolving this plane region indicated by blue lines about the x-axis. So again I repeat, here we are given this plane region shaded by these blue lines. We are rotating this plane region about the x-axis and we obtain this solid of revolution. Now to find out the volume of this solid, we consider the cross section of this solid perpendicular to x-axis, and that cross section is a circular disc with radius y. So base area of this disc is pi into y square and thickness is delta x. Therefore we have this formula for the volume of solid of revolution, pi into y square dx, and y is given by x square, so we substitute y equal to x square, and by integral we obtain that value of volume is 31 pi divided by 5. Okay, so this is the disc method, and we have taken rotation about the x-axis. We can have rotation about y-axis as well as rotation about any vertical or horizontal line also, that we will discuss in upcoming lectures. This question was asked in GTU Winter 2016 exam. So this is easy. You just have to remember that how this formula is coming. So this is all about this session. I hope you like it. Thank you very much.